How are you? Enjoying the numerical? P and Q made of the same material. Two wires, P and Q, are made of the same material, means density of P is equal to density of Q. Rho P is equal to rho Q is equal to, say, rho. Are under the same tension. Tension in the wire P is equal to tension in the wire Q is equal to, say, T. The length of the wire Q is 1.2 times that of the wire P. Length of the wire Q is 1.2 times length of the wire P. And its radius is 90% of P. Radius of Q is 90% of radius of P. When the wires are made to vibrate together, 8 beats are heard per second. When both the wires are vibrated together, 8 beats are heard, means NP minus NQ or NQ minus NP is equal to 8 hertz. पिछला chapter, phenomenon of beats. Find the fundamental frequencies of the wires. उनके fundamental frequencies find करना है, मतलब fundamental frequency of P and fundamental frequency of Q. Fine. First of all, N is 1 upon 2L under root T by M, fundamental frequencies. Then, for both the wires, the densities are given, means you have to write it in the form P upon rho pi r square, or if r is taken out, r will be here. Now check from the data. Both the wires are having same density and same tension. Same densities and same tension. Means these are constants. I is a constant. 2, the number, is also a constant. Means N is inversely proportional to LR. So NP upon NQ will be equal to inverse proportion. So LQ upon LP into RQ upon RP. Correct? So put the values now. NP upon NQ will be equal to LQ is 1.2 times LP upon LP into RQ is 90% of RP, means 9 by 10 or 0.9 RP upon RP. This LP gets cancelled, RP gets cancelled. So NP upon NQ is equal to 12 nines are decimal after 2 digits. So NP upon NQ is 1.08, or you can say NP is 1.08 times NQ. NP is 1.08 times NQ, means NP is greater than NQ. NP is greater than NQ, means it is NP minus NQ. NP minus NQ is equal to 8 hertz. So you decided whether it is NP minus NQ or NQ minus NP. NP is greater, so it is NP minus NQ. So now NP minus NQ is equal to 8. We found that NP is 1.08 times NQ. So 1.08 NQ minus NQ is equal to 8, or 0.08 NQ. दोनों का subtraction is equal to 8, or NQ is equal to 8 upon 0.08. That is equal to, if you shift the decimal, it is 800 upon 8. That is 100 hertz. So frequency of Q is 100 hertz. So fundamental frequency of P will be 1.08 into 100, that is 108 hertz. So frequencies of the two wires are 100 hertz and 108 hertz. A sonometer wire under constant tension. The tension in the sonometer wire is not changed. Under a constant tension, resonates with a tuning fork. The wire resonates with the tuning fork, means frequency of the wire is equal to frequency of the fork. So capital N frequency of the fork is equal to small n frequency of the wire. Resonates with the tuning fork when the length of the wire is 65 centimeter. L is equal to 65 centimeter. When the length of the wire is increased by 1 centimeter, length change होगी, मतलब wire की frequency change होगी. So this was N1 and this was L1. When the length was 65 centimeter, the wire resonates with the tuning fork. When the length of the wire is increased by 1 centimeter, means L2 is equal to 65 plus 1, that is 66 centimeter. When the length of the wire is increased by 1 centimeter, 5 beats are heard per second. Means N1 minus N2 or N2 minus N1 is equal to 5 hertz. Find the frequency of the fork. Capital N, that is N1, हमको find करना है. Length increase हुई तो frequency क्या हुई? Decrease हुई. N is inversely proportional to L from the formula. N is equal to 1 upon 2L under root T by M. Tension constant है, mass per unit length constant है, means N is inversely proportional to L. L has increased, means frequency has decreased, means N1 is greater than N2. पहली frequency ज़्यादा थी, length बढ़ गई, तो अब frequency कम हुई. Means this is N1 minus N2 is equal to 5. Correct? Then, as N is inversely proportional to L, we got one relation here. From this you can say N1 upon N2 is equal to L2 upon L1. So N1 upon N2 is equal to 66 upon 65. So N1 is equal to 66 N2 upon 65. This value of N1 you put here. So, or we have to find N1. तो N1 को ऐसे ही रखो. N1 minus N2 की जगह हम लिखेंगे 65 N1 upon 66, क्योंकि हमको N1 frequency of the fork find करना है, मतलब N1 find करना है. So let N1 be N1. N2 की जगह पर हम लिखेंगे 65 N1 upon 66. 65 N1 upon 66 is equal to how much? 5. 66 N1 minus 65 N1, that is N1 upon 66 is equal to 5. So N1 is equal to 5 into 66. 5 6 are 30, carry 3. 5 6 are 30 plus 3, 330. So N1 is 330 hertz, means frequency of the fork is 330 hertz. A tuning fork produces 6 beats per second with a sonometer wire when it is either 95 centimeter long or 100 centimeter long. वायर की लेंथ जब 95 सेंटीमीटर है तब, और वायर की लेंथ जब 100 सेंटीमीटर है तब भी, दोनों बार ट्यूनिंग फोर्क प्रोड्यूसेस 6 beats per second with that wire. So first length of the wire is 95 centimeter, L2 is 100 centimeter, and in both the cases tuning fork is making 6 beats per second with the wire, means n minus n1, जब लेंथ l1 थी तो फ्रीक्वेंसी थी n1, is 6 hertz, and n minus n2 or n2 minus n1 is also 6 hertz. In both the cases, the tuning fork makes 6 beats per second with the wire. Find the frequency of the tuning fork. Capital N is equal to what? First, we'll have to decide this. कौन सा बड़ा है, कौन सा छोटा है? So N is inversely proportional to L. L1 is less than L2, means N1 is greater than N2. Inverse proportion, L छोटा तो N बड़ा, तो N1 is greater than N2. अब N1 N2 से बड़ा है, and tuning fork produces 6 beats per second with both N1 and N2. Such type of question we have seen in the previous topic, waves में. तो इसका मतलब फोर्क की फ्रीक्वेंसी दोनों के बीच में रहेगी, इधर भी नहीं, इधर भी नहीं, because fork is producing 6 beats with both, means frequency of the fork is in between the two, means N1 is greater than capital N is greater than N2. So the first equation, N1 is greater than capital N, means this will be N1 minus N is equal to 6. Second equation, N is greater than N2, means N minus N2 is equal to 6. दोनों को ऐड करो तो N1 minus N2 is equal to 12. So you got the relation N1 minus N2 is equal to 12. Again from here, N1 upon N2 is L2 upon L1. Therefore, N1 upon N2 is equal to L2 upon L1, 100 upon 95. (20 upon 90) means N1 is 20 N2 upon 19. This value of N1 you put here. So N1 की जगह पर 20 N2 upon 19 minus N2 is equal to 12. अब इसको सॉल्व करो, 20 N2 minus 19 N2, that is N2 upon 19 is equal to 12. So N2 is equal to 12 into 19, carry 10, 228 hertz. That is N2, or N will be 6 plus N2. N minus N2 is 6. N2 had 228. So N will be 6 plus 228. That is 234. So frequency of the fork will be 234 hertz. मैंने fast explain इसलिए किया हूँ because such type of questions we have solved previously. A sonometer wire under tension vibrates in unison with the tuning fork. It vibrates in unison with the tuning fork, means their frequencies are equal, means frequency of the fork is equal to frequency of the wire. If the tension is increased by 1%, tension change हो रहा है तो frequency change होगी, means this is N1 initial condition, frequency of the fork is equal to initial frequency of the wire. If the tension is increased by 1%, T2 is equal to 101% of T1. Increased by 1% means it becomes 101% of the original. 3 beats in 2 seconds are produced. मतलब जब टेंशन चेंज हुआ तो फ्रीक्वेंसी चेंज हुई. So N1 minus N2 or N2 minus N1 is 3 beats in 2 seconds. Means this is 3 by 2, that is 1.5 hertz. So number of beats heard is 1.5. Find the frequency of the fork. Capital N is equal to what? Very very simple. लेंथ चेंज किए थे हमने, अब यहाँ पर लेंथ कांस्टेंट रखी है और टेंशन चेंज किया हुआ है. सो n is directly proportional to root t. n is equal to 1 upon 2l under root t by m. So n is directly proportional to root t. T2 is greater than T1. Therefore n2 is greater than n1. टेंशन बढ़ गया मतलब फ्रीक्वेंसी बढ़ गई. Means this is n2 minus n1 is equal to 1.5. You got one relation. Then from this, n1 upon n2 is under root t1 upon t2. So n1 upon n2 is equal to under root t1 is t1 upon t2 is 101 t1 upon 100. This t1 gets cancelled. So n1 upon n2 is equal to under root 100 upon 101. You'll have to solve it using log table because we want exact answer, and put that value of n1 or n2 here. You'll get the value of frequency of the fork, that is n1. Now I hope you can solve it on your own and solve it. A sonometer wire of length 90 centimeter horizontally. Length of the wire is 90 centimeter. Is under a constant tension. Tension is not changing. Where should a bridge be placed below the wire? जब ये वायर है, वायर के बीच में कहीं पर हमको ब्रिज रखना है. When you put the bridge below the wire will be divided into two segments. तो पूछ रहा है कि कहाँ पर रखना है, so that the two segments can emit notes whose frequencies are in the ratio 2:1. ये जो दो segments बने हैं, इनके frequencies का ratio होना चाहिए 2:1. Means अगर suppose ये length को हम बोलते हैं L1, इसको बोलते हैं L2, तो N1 upon N2 should be equal to 2 upon 1. Where should the bridge be placed? What is the relation between N and L? N is inversely proportional to L. So N1 upon N2 is equal to L2 upon L1. N1 upon N2 is 2 upon 1 is equal to L2 upon L1. Means L2 is equal to twice L1. L2 is equal to twice L1. And total length is L. Means L1 plus L2 is 90 centimeter. L1 plus L2 is 90 centimeter. L1 plus L2 is twice L1 is 90 centimeter. So 3L1 is equal to 90 centimeter, or L1 is equal to 30 centimeter. L1 is equal to 30 centimeter, means L2 is equal to 60 centimeter. Means bridge should be placed at 30 centimeter from one end or 60 centimeter from the other end. A wire having a linear density of 4 into 10 raised to minus 3. Linear density 4 into 10 raised to minus 3 kg per meter is stretched between two rigid supports with a tension of 40 Newton. It is observed that the wire resonates at a frequency 250 Hz. वायर की एक फ्रीक्वेंसी है 250 हर्ट्ज. वायर रेजोनेट्स एट 250 हर्ट्ज, मतलब उसकी फंडामेंटल फ्रीक्वेंसी नहीं है, कोई एक फ्रीक्वेंसी 250 हर्ट्ज है. द नेक्स्ट हायर फ्रीक्वेंसी at which the same wire resonates is 300 hertz. मतलब वायर की एक फ्रीक्वेंसी है 250 हर्ट्ज और उससे हायर फ्रीक्वेंसी है 300 हर्ट्ज। अब वो कौन सी फ्रीक्वेंसी है हमको मालूम नहीं, वी डोंट नो विच हार्मोनिक इट इज। तो हम बोलेंगे कि वो पीथ हार्मोनिक है, मींस फ्रीक्वेंसी ऑफ पीथ हार्मोनिक। सो फॉर पी एन इज इक्वल टू 250 हर्ट्ज। किसी एक हार्मोनिक पी नंबर के हार्मोनिक के लिए फ्रीक्वेंसी है 250 हर्ट्ज और उससे अगली फ्रीक्वेंसी मतलब फॉर P+1 हार्मोनिक अगली फ्रीक्वेंसी है ना। थर्ड हार्मोनिक के बाद में क्या आएगा? फोर्थ हार्मोनिक। फोर्थ हार्मोनिक के बाद में क्या आएगा? फिफ्थ हार्मोनिक। P नंबर के हार्मोनिक के बाद क्या आएगा? P+1 हार्मोनिक। फॉर P+1 द फ्रीक्वेंसी इज 300 हर्ट्ज। फाइंड द लेंथ ऑफ द वायर। हमको वायर की लेंथ फाइंड करना है। ओके, ये क्वेश्चन समझ लो अच्छी तरह से। वायर की कोई फ्रीक्वेंसी 250 हर्ट्ज है, मतलब वो फंडामेंटल फ्रीक्वेंसी नहीं बोल रहा है, कोई एक फ्रीक्वेंसी उसकी 250 हर्ट्ज है, मतलब फॉर हार्मोनिक नंबर P the frequency is 250 hertz. For the higher frequency, for the next harmonic P+1, n is equal to 300 hertz. Now here we know that n is equal to P upon 2L under root T by M. P हार्मोनिक के लिए n है 250 hertz is equal to P, we don't know how much it is, upon 2L under root T by M. क्योंकि बाकी कुछ चेंज नहीं हो रहा है। और नेक्स्ट हार्मोनिक अब n है 300 हर्ट्ज इज इक्वल टू P+1 अपॉन 2L अंडर रूट T बाय M। पीथ हार्मोनिक P+1 हार्मोनिक, दोनों का रेशो लो। 250 अपॉन 300 विल बी इक्वल टू P अपॉन P+1। बाकी सब हो जाएगा कैंसल। सो हियर नाउ 5 5 जा 5 6 जा, क्रॉस मल्टीप्लाई करो। 6P इज इक्वल टू 5P प्लस 5। 6P माइनस 5P, P इज इक्वल टू 5। मतलब ये जो 250 हर्ट्ज है ये कौन सा हार्मोनिक है? फिफ्थ हार्मोनिक है। मीन्स 5n is equal to 250 hertz, means n is equal to 50 hertz, means fundamental frequency of the wire is 50 hertz। आपको फाइंड करना है L। तो अब क्या करेंगे? You know how much is the fundamental frequency, so now we'll use the formula n is equal to 1 upon 2L under root T by M। n की जगह पर लिखेंगे 50, L हमको फाइंड करना है, T is given, M is also given, you'll get the length of the wire। मतलब ये सब कुछ जो करना है ये किस लिए करना है कि ये 250 हर्ट्ज कौन सा हार्मोनिक है ये फाइंड करने के लिए हमने ये किया कि n इक्वल टू P अपॉन 2L अंडर रूट T बाय M। फिर 250 हर्ट्ज फ्रीक्वेंसी है तो वो P नंबर का हार्मोनिक है अपॉन 2L अंडर रूट T बाय M। नेक्स्ट हायर फ्रीक्वेंसी है 300, मतलब P की जगह P+1, सो यू गॉट द वैल्यू ऑफ P। P इज इक्वल टू 5, मतलब ये फिफ्थ हार्मोनिक है। ये फिफ्थ हार्मोनिक है मतलब फंडामेंटल फ्रीक्वेंसी है 50 हर्ट्ज। फंडामेंटल फ्रीक्वेंसी है 50 हर्ट्ज, so putting the formula for fundamental frequency you get the value of length of the string। Rest of the things we shall see in the next lecture, so have a nice time, good day, bye bye।